Often overlooked in favor of its brighter neighbors, Mercury may hold secrets that challenge our understanding of the solar system. Recent data from the James Webb Space Telescope suggests that Mercury may have had life forms in the past. This unassuming planet may be completely different from what we have long believed, and it hides amazing discoveries before our eyes. Mercury, hidden at the center of our solar system, has rarely been the subject of groundbreaking discoveries. But recent observations from the James Webb Space Telescope lead scientists to suspect that Mercury has secrets that have been hidden until now. The rocky planet Mercury, slightly larger than Pluto and significantly smaller than Earth or Mars, was previously thought to be too hot for life or vegetation. However, scientists have discovered bodies of water on Mercury that could radically change our understanding of this world. Mercury is not the hot, lifeless world we once thought. Large basins, such as the Caloris Basin, which has more than 1,500 kilometers in diameter, open up striking landscapes. Scientists call these structures rocks, which can be several kilometers long and up to 3 kilometers high. Other typical Mercury landscapes include hollows, small, discrete depressions probably formed by the sublimation of elements such as sulfur and potassium. The poles of Mercury are permanently covered with craters that keep them cold enough to hold ice. This discovery is surprising because scientists have long believed that Mercury is too hot to hold water permanently. The true temperature of Mercury reveals a world of extremes. Despite these extremes, Mercury is by no means a boiling inferno like Venus. Temperatures vary, 427 degrees Celsius during the day, but drop to around -173 degrees Celsius at night. Scientists attribute these extremes to the planet's almost non-existent atmosphere, which cannot store or dissipate heat. While Venus has one of the densest atmospheres in the solar system, creating a greenhouse effect that heats the planet up to 467 degrees Celsius day and night, Mercury shows that it can have temperate regions. This raises the troubling question of whether life can exist in such fringes, shadowy craters, or under large rocks and hidden rocks. Discovering the world of aliens hidden behind the eyes is an incredible opportunity. The Greeks discovered Mercury as early as 265 BC. On the scale of our solar system, Mercury is like a pin-sized, visible only in simple telescopes when it passes in front of the sun. The Greek astronomer Tis was the first to record the position of a planet in the sky. But only the introduction of modern telescopes in the 17th century allowed astronomers to make more detailed studies and better classify Mercury. In 1631, the French astronomer Pierre Gassendi was the first to describe the passage of Mercury in front of the Sun and to calculate its orbit. In 1771, German astronomer Jan Hermann Schurz studied the orbit of the planet, but mistakenly thought that it is related to the Sun as the Moon is to the Earth. This misconception lasted until 1859. When French astronomer Urbain Le Verrier noticed anomalies in the orbit of Mercury that could not be explained only by the gravity of other known planets. He hypothesized that there was a previously unknown planet called Vulcan between Mercury and the Sun. Although the existence of Vulcan was never proven, Albert Einstein's theory of general relativity explained the anomalies in 1915, when the search for Vulcan ended. Amazingly, thanks to the Mariner 10 spacecraft, we have detailed maps of Mercury's surface since 1974. This probe revealed the smallest details of the surface of Mercury with unusual sharpness. A NASA probe flew very close to Mercury 3 times and took the first close-up pictures of the planet. These images showed craters and landscapes and provided measurements of the planet's environment, showing that Mercury has a thin helium and hydrogen exosphere and a weak magnetic field, which is surprising given the planet's small size. After the 1970s, the search for Mercury was stopped. NASA cited difficulties in building and navigating the probe due to the gravity and extreme conditions of the Sun. However, in 2008, NASA launched the Messenger mission, which successfully reached Mercury's orbit in 2011. By 2015, Messenger provided new insights into the geological history of the planet, including evidence of volcanism, vast lava plains, and polar water ice. Craters. This evidence showed that Mercury was and is geologically active, suggesting that we may have misjudged its past. Some scientists believe that Mercury was once located elsewhere in the solar system and then Jupiter's gravity pushed it closer to the Sun. If Mercury was once in the habitable zone, there could be life there. Some of the landscapes on Mercury resemble rocky worlds like Earth or Mars. It is possible that Mercury was once temperate. The James Webb Space Telescope sheds light on these questions. By looking at planets like Jupiter and Uranus, scientists have gained new insights into the gas and ice giants. They hope to do the same with Mercury by using special filter techniques to scan the Sun around Mercury. The James Webb Space Telescope is practically designed for this task, capturing even small exoplanets passing stars. In our own solar system, tiny Mercury in front of the giant Sun is like a dot. The telescope detects minimal fluctuations in light and clearly distinguishes the light reflected by Mercury from the light coming from the Sun. If successful, we will obtain even more detailed information about the chemical composition of Mercury's surface. Scientists hope these scans will reveal whether Mercury is lifeless or has structures and features we've previously missed. More signs of water on the planet would be spectacular, forcing the scientific community to recognize Mercury as a much more complex and mysterious world than previously thought. Often overshadowed by its more prominent neighbors, Mercury offers surprises that continue to fascinate scientists. In addition to extreme temperatures and a thin atmosphere, recent observations have revealed complexities that challenge our understanding of this tiny planet. Mercury has evidence of a turbulent past characterized by volcanic activity and tectonic movements. The planet's surface is scarred with numerous impact craters, suggesting a history of heavy bombardment. Caloris Basin, a huge crater more than 1,500 kilometers in diameter, bears witness to these ancient cataclysms. These craters are surrounded by large plains, probably formed by volcanic eruptions that once shaped the landscape of Mercury. These geological features provide insight into the evolution of the planet and raise questions about its internal processes. Mercury's proximity to the Sun affects its environment in unique ways. As we continue to explore Mercury, we will uncover more of its secrets, challenging our assumptions and expanding our understanding of the solar system. Each discovery brings us closer to unlocking the secrets of this most enigmatic planet, revealing a world far more fascinating and complex than we ever imagined. Despite its extreme conditions, Mercury presents a fascinating puzzle to scientists. Its thin atmosphere, composed mainly of oxygen, sodium, hydrogen, helium, and potassium, suggests an interaction with the solar wind that is unique among terrestrial planets.
This delicate exosphere is constantly replenished by the influence of the solar wind and micrometeorites, creating a dynamic environment that challenges our understanding of planetary atmospheres. The presence of water ice in permanently shadowed craters near Mercury's poles adds a new layer of complexity, raising questions about how such ice deposits could survive despite the planet's proximity. Another mystery lies in Mercury's magnetic field. Unlike Mars and Venus, which lack significant magnetic fields, Mercury has a surprisingly strong magnetic field, about 1% as strong as Earth's. This field is thought to be generated by a dynamo effect in the partially molten, iron-rich core of Mercury. The planet's magnetic field interacts with the solar wind to create a magnetosphere that is both unique and fascinating, especially considering Mercury's small size. Understanding this magnetic field can provide important insights into the magnetic history of other planets, including Earth. Exploration of Mercury's interior continues to yield surprising discoveries. Messenger data showed that the core of Mercury is about 85% of the planet's radius, which is proportionally much larger than the Earth's core. This massive core contributes to the high density of the planet and suggests a different formation history compared to other terrestrial planets. The presence of sulfur in surface rocks indicates that Mercury may have formed under different conditions, perhaps in some part of the solar nebula that was richer in volatile elements than previously thought. As the James Webb Space Telescope and future missions continue to study Mercury, scientists hope to uncover even more mysteries. New techniques and instruments will enable more detailed observations of Mercury's surface and atmosphere, providing deeper insights into its geological and chemical composition. These discoveries could challenge long-held assumptions about the planet and may even provide clues about the formation and evolution of the early solar system. Each new piece of information brings us closer to understanding this enigmatic world, proving that Mercury, although often overlooked, is a planet full of mysteries waiting to be discovered. The European Space Agency's Bepi-Colombo mission, currently on its way to Mercury, promises to further change our understanding in the coming years. Equipped with an advanced instrument designed to map the planet's surface in unprecedented detail, analyze its exosphere, and study its magnetic environment, Bepi-Colombo will try to solve the mysteries left behind by Messenger. Once it is completed and possibly placed into orbit, scientists will eagerly await information that will shed light on Mercury's formation, evolution, and role in the larger story of our solar system's history. With each revelation, Mercury reveals not only more about itself, but also about the complex and dynamic processes that shaped the cosmic neighborhood.